Hey, my name's Alex, and I'm gonna be going through how to identify whether a compound is aromatic, anti-aromatic, or non-aromatic. So I have listed right here the criteria that you need to follow to determine which of the three it is. So it needs to be cyclic, it needs to be planar, conjugated, and it needs to follow a 4n+2 rule to be aromatic. Similarly, we have anti-aromatic, which follows the same three first rules, but anti-aromatic follows an 4n rule. And then if it doesn't follow one or more of these rules, it's non-aromatic. So moving on, I have a benzene ring, and just want to explain how this connects to these three. So a benzene ring has an sp2 right here, here, and just all across. So from here you can determine that it also has the pi electrons, and we have 2 here, another 2 here, and another 2 here. So from there you can determine that it's aromatic because it follows all these criteria. So okay, then from here I have a few examples written out for us. First step is going to be just to determine the hybridization. So these bottom 4 are all sp2, and this top one to the hydrogens present is going to be sp3. Now this is considered an isolated carbon, so that's going to tell you that this is a non-aromatic because it's not conjugated, and it's definitely, well, even though you have two pi electrons on each, right? Well, you have 4 total. It doesn't follow anti-aromatic because it's not conjugated. So following from here, we have a negative charge present in this compound. Just right away, we have 4 total pi electrons. We have sp2 on the bottom, and then we have this lone pair up here. Now, a lone pair present is going to indicate that it may contribute to the conjugation. So in this case, it's true because this lone pair will also result in a in resonance stabilization. So you can see that this lone pair could make this movement, but overall you can count these up. You have 2, 4, 6 pi electrons, and that is going to scream out to you that it is aromatic because it follows the 4n+2 rule. Alright, following this we have a positive charge present. So similar to this, we have not n+2, but rather it's sp2 right here, and we have hydrogen present. So we have sp2, and this is going to be considered to be anti-aromatic because we have 2 pi electrons here and another 2 here, which follows our 4n rule. So this one, just from that alone, tells us that it's anti. Okay. Now in this example, we have an oxygen present. So when you see a heteroatom, first thing you want to do is put the lone electron or the lone pairs. So from that, you're gonna think that you have a contribution from these lone pairs. So just taking from these two, you have 2 pi electrons, 2 from here and 2 from here. Now just a little extra step, again, just indicate your hybridization, but again you have 2 pi electrons here, 2 pi electrons here, and another 2 here. So that's going to follow the 4n+2 rule, which indicates that it's aromatic. Okay, following this we have a nitrogen as our heteroatom. Similar rules indicate your hybridization, all sp2. You have 2 pi electrons here, another 2 right here, and then put in your lone pair. This lone pair is going to contribute, so we have another 2. We have 6 total, and that's going to indicate that this is also aromatic. Okay, now following this, first step, I'm going to put your lone pairs, oh, my mistake, just another lone pair. And so in our previous problems, we've indicated that a lone pair is going to contribute. But in this particular case, we're not going to have that because you can see that we already have our conjugated set. So we're going to have 2 here, another 2 here, and another 2 here. These lone pairs are not going to be contributing, so do not consider those. So this is going to tell us that this compound is aromatic. Okay, and lastly, we have another compound with nitrogen in it, and we have 2 pi electrons, another 2 right here, and we also have our lone pair right here. Now, even though we have this lone pair, it doesn't contribute to the overall conjugation, because we see that we have this sp3 present, and that is isolated. So going back to our first problem, we know that if it is isolated, then it must be non-aromatic, because it does not follow the rule to be that a compound has to be conjugated, and if it's not conjugated, it's non-aromatic. All right, well, that's all I have for you. Best of luck with Orgo 2.